Okay, grade 8. We are starting term 3. And in term 3, this is chapter 9. In chapter 9, your first lesson is on scatter plots. Wait, I start here. Okay, so chapter 9, we're going to do scatter plots and data analysis. You're going to collect a lot of data. Okay, you're going to graph. So you should know all this vocabulary over here: bivariate data, distribution, all this 5-number series, 5-number summary, line of best fit, mean absolute deviation, qualitative data, all that quantitative data, relative frequency, scatter plot, standard deviation, symmetric, two-way table, univariate data. So all this you need to know. You have to know. Okay, so let's start lesson 1. Lesson 1 is on scatter plots, and the vocabulary that you need to know for lesson 1 is bivariate data and scatter plots. You need to know, you need to be able to explain what is bivariate data, and you need to be able to explain what is a scatter plot. Okay, so we come here. What is bivariate data? It is data that needs 2 variables or 2 numerical observations. So one, it is data. So that means you need to put it on a graph. Okay, well, it starts with a table and then a graph. So you'll have a table, an X and Y table, just like we did in term 1. And then you'll have X values and you'll have Y values. The X values will go on the X axis, the Y values will go on the Y axis, and the 2 numbers, the X number and the Y, the X value and the Y value make a point. Okay, for you to have a point, you need the X coordinate and the Y coordinate, and the point is labeled as ordered pair. Okay, ordered pair. So you start with a table, which means you collected data. After you collected data, now you will draw a graph. But so now we are saying bivariate data, you need 2 variables or 2 numerical observations. So if I go to the doctor will measure my height and weight. Okay, usually that's what the nurse does before the doctor sees you. They measure your height. So they will say, when you came in January, you are 30 kilograms. You are 5 feet 6 inches, and your weight maybe 100 kilograms. And then when you came the second time, they measured you. Maybe your height might not grow so much, but there could be a difference. Either you're losing height, which happens, okay? So here we are measuring height and we are measuring weight. So my first variable is height, my second variable is weight. Okay, here marks for science and marks for math. So I'm comparing your marks for math and marks for science. Okay, so I say in term 1 or your first quiz, you got 90% in math and 60% in 90% in math and 60% in science. And then your second quiz could be you got 10% in math and then you got 70% in science, like that. So you have to label your points. Okay, here we could be measuring temperature and rainfall. So the temperature of a place and rainfall. So you'll collect them like this in a table. You'll have values over here, like this one. Do you see? Like this table. And then you plot them. Okay? You plot them on the graph, just like they did over here. So here 1 goes with 31.7, and they did that. So if you compare the values on this table and the values on the graph, okay? Now, notice from 0 to 20, there is this line. This thing over here means they have skipped some numbers. That means you're missing 0 to 19. They started at 20. 0 to 19 was not important for them, okay? Because their lowest number was 22.1. So they didn't need 1, they didn't need 2, they didn't need 13. So they needed from 20 onwards. So that's why the Y values started from there, from 20 like that. And remember, you have to go by scale. So if this is 20 and then you say 24, that means you added 4. So you add 4 to 24, you get 28. You cannot write 20, 24, 25, 26. No. You're saying every box on Y is 4. So 24 plus another 4 is 28. 28 plus another 4 is 32, like that. Okay? And you see here, every box is 1. Every box is 1. From 0 to 1 is 1. From 1 to 2 is another 1, like that. So you must make sure you have a good scale. Your scale cannot change. If you look over here, your scale on the x-axis is 5. Every box is 5 units. The scale on the y is 1. Every box is 1 unit. Here, the scale is every box is 4 units. Starting from this line, every box is 4 units. Here, every box is 1 unit. Okay. All right. What is a scatter plot? It is a graph. You need to know that. Oh, I didn't finish explaining. Sometimes it can be given as a graph. Sometimes it can be given as a story. And then you need to plot the points that they give you. So here I am comparing how many students Miss Lillian has taught in grade 8 for the last 10 years. The numbers will not be the same. Okay? All right. So scatter plot, it is a graph. It shows a relationship between bivariate data. When you put things in a graph, you are showing a relationship. When you put things in a table, when you put data in a table, you're showing a relationship. Okay? And you have to write them as ordered pairs for you to graph them. Okay? Remember, ordered pair, you need a number for x and a number for y. So this is called the x coordinate and this is called the y coordinate. And they are, because they are two, we call them an ordered pair. Okay? Things you must know in this lesson. You must know how to read a table correctly. You need to know how to label the graph correctly. That means you need to know what variable goes on x, what variable goes on y. You need to know that. X and y axis, you need to know where they are placed correctly. You need to label your axis with the variable that you're measuring. Okay? You need to know how to plot correctly. You plot x, then you plot y. You never plot y and then x. It is x and then y. You learned this in grade 3, grade 4. We learned this in term 1. Okay? And you need to know how to answer the question that was asked correctly. Do not answer a question you were not asked. Okay. Now, so scatter plot shows associations. There is 2 types of associations. One, variable association, and the second one, linear association. Now, variable association is divided into 3 other parts. So you have a positive association. I didn't write, but positive association. You have a negative association. And you have no association, okay? And then when it comes to linear, linear is divided into 2. Linear and non-linear association. Now, what is a positive association? If your points are going up. If your points are going up, then you're positive, okay? And how do you describe it? As x increases, that means x is going to the right. Y is also increasing. Your points on y are increasing. You see, your line is going up. So, Positive means you use increase, okay, on both X and Y. Negative means your line is going down. You see your line is going down? Now your line is going down when Y is decreasing. So X will always increase, Y will decrease. So how do I know X is increasing? Because I started on 0 and I'm going to the right. How do I know Y is decreasing? It's because I started up and I am going down. So that is how I know this is decreasing. And because it is decreasing, they have a negative association. Okay? Now, number of us, here this one is no association. When your points are everywhere, they don't follow a pattern. That means they are not straight or they are not together in a pattern. So since, look, these are everywhere, because they're everywhere, we say no association. And how do we describe it? We say there is no correlation because the data does not have a relationship. As in, there is no relationship because your points are not following a pattern, okay? Because there is no pattern. Now, we come and describe linear. Linear association can be divided into two, positive or negative, okay? So if your points are going up in a straight line, then it is linear and it is positive. The data points make a line. And then if it's going down in a line, remember you have to see a line. So it is linear and it is negative, okay? Non-linear, you can have positive and negative. Your data points are not making any line. The shape is curved. Shape is curved. You see it's making like an S or a C, like that. It is not a straight line. So the shape is curved, you are non-linear. You're looking like an S. If you look like an S, like that, or like waves, then you're non-linear, okay? If you're straight, then you're linear, okay? Now we need to describe what is an outlier. So when you're plotting points and you see a point out here like this, it doesn't mean you're wrong. It happens. It happens that sometimes some data points are not together with the rest. And if you're not together with the rest of the data points, you're called an outlier. So points that are far away from most of the data points is what we are calling the outlier. Okay? And then you have the cluster. So those points that want to be together in one group. So points that are together in one group are called a cluster. Okay? They are close together. Like you see here, they are close together. The rest are a little bit separate from the rest. So it is called a cluster when your points are together. All right. Here, you'll be asked to analyze your scatter plot. When you analyze your scatter plot, you need to tell me 4 different sentences. 4 different sentences. So when analyzing the shape of your distribution of a scatter plot, so that means you need to look at your graph. You need to tell me, is it positive or is it negative or there is no association? You have to choose one of these. You cannot choose all 3. So you might say my scatter plot is positive, like that, because the points are going up. Oh no, because as X is increasing, Y is increasing. Don't tell me because the points are going up. You say because X is increasing, Y is also increasing. When you're describing negative, you will say as X is increasing, Y is decreasing. Okay? And here you say, when you say no association, is because there is no pattern. Because my data points are not following a specific pattern. Or they don't have a relationship. Okay? Then you must tell me whether it is linear or non-linear. You have to use those points. So you have to say my points are lying close to a line when it is linear. My graph is a curve when it is non-linear. Okay? And then you need to tell me if there is an outlier or there is no outlier. And if there is an outlier, you need to tell me. You need to tell me the number, the point. Let's say this is 250, like that. So the point 250 is an outlier, like that. So you describe the outlier like this. And then you need to tell me about the cluster. Either the cluster is at the beginning, or the cluster is in the middle, or the cluster is at the end. Because the cluster doesn't necessarily mean it's going to be here. You can have a graph like this, and your cluster is somewhere here. Or majority of your points are together over here, and then you have a few like this and a few like this. Or you can have another graph like that. Okay. So your cluster can be at the beginning, at the end, in the middle. It doesn't have to be. So you have to say, in the middle of my data, and you circle, this is my cluster. When you're identifying your cluster, you need to circle and label cluster. Like that. Even here, when you're defining the outlier, you need to circle and say outlier. Okay? And that is it. So, please do example A. You need to do example A. And you need to do example B and C and D. And then we will talk about them when we come to class. Bye.